Hello everyone. Today let us learn how to do multiplication using Booth's algorithm. So I've taken signed numbers and I'm going to do the multiplication by applying Booth's algorithm. So what is this Booth's algorithm and how does the process of multiplying these two signed numbers? As an example, I've taken minus 7 and 3 here. Minus 7 is the multiplicand and plus 3 is the multiplier, and minus 21 is the product or the result which we get after multiplying these two signed numbers. Okay, now this is the flowchart of Booth's algorithm. What does it state is once I begin the process, I'm going to do the initialization of certain parameters. What are those parameters? Those are on multiplicand, which will be represented with term m, q multiplier, q naught. We will come to know about it as we go forward. A is the content of the accumulator, which will be initialized to 0. N indicates the number of bits. Here, the number of bits used to represent the multiplicand and multiplier. Okay, this will also tell us number of cycles I'll be going through in order to get the final result after multiplying the bits. Okay, so let's go back to the example which I've taken. So minus 7, I'm sorry, minus 7 in binary is 0 1 1 1, and plus 3 is 0 0 1 1 in binary. So I have to create a table like this, okay, with all the initialized values for these four terms. N is equal to 4, A is the accumulator content, 0 initially, q is the multiplier which is 30011, and q naught is 0. So how did I get this q naught? If I say, how do I call these bits? I have 4 bits, right? So it is like q naught, q1, q2, q3. If I'm starting from q1, q2, q3, q4, this will become q naught. Q naught is the previous value of the number. Okay, the multiplier number. So this indicates the previous value. The previous value will always be 0. That is what we are assuming and initializing it. Okay, so if I'm starting from q naught, it will be q1, q2, q3, q4. If I'm taking it as minus 1, then it will be q1, q naught, q q1, q2, q3. Some of the books they use q minus 1, and in this explanation I've used it as q naught. Okay, so we have initialized it. Next, what is the step? Now we have to follow the flowchart. What does the flowchart says? We have to know the values of q1 and q naught. The value of q1 is 1 here. The value of q naught is 0. Let's go back to the flowchart. So what does it says is once you initialize it, find out the values of q1 and q naught. The value of q1 and q naught was 1 and 0. If it is 1 and 0, I have to do certain process. What is that? I have to minus the content of the accumulator with the multiplicand. If it is 0 1, I have to add the content of the accumulator with the multiplicand. If it is 0 0, I have to do the arithmetic right shift of the contents which is present in accumulator, multiplier, and q naught for both the conditions 0 0 1 1. So these steps, let us do it now. So let us go back to the table. So I have identified 1 and 0. That means I have to do A minus M. Content of the accumulator will be minus with the multiplicand. So the multiplicand is minus 7 here. In binary it is 0, 1, 1, 1. So how do I do it? A minus M means here M is minus, having a minus value. So A minus M minus sum is nothing but you're actually adding the content of the accumulator with the multiplicand. So accumulator content will be 0, 1, 1. Okay. Next, this q value will always remain the same. So I'm taking it down here 0, 0, 1, 1. And what is q naught now? Again 0. So I have performed the application A minus M here. Now go back to the flowchart and see what I'm supposed to do. Once I do A minus M, I have to do the arithmetic right shift of the Q, A, Q and Q naught. So I have to do the arithmetic right shift here. So I will retain this 0 here and start shifting the number 1 bit towards right. So 0 will come here, 1, 1, and this 1 will be here, then 0, 0, 1, 1. So that is how the arithmetic right shift is done. So once I did my arithmetic right shift, what do? I have to minus the number of bits with 1. So n is 4 for us, n minus 1 will give us 3. Now I have to check whether n is equal to 0. If n is equal to 0, that means my result is already obtained. So I have to not to go through any of the process again. I can simply find out the result which is present in AQ and close the process. Now, if n is not 0, now what is the n value we got? 3. So then what should I do? I should go back and check for the values of Q1 and Q0 and repeat the process. Now, for us, n is 3 now. Let's do the process. Now, n is 3. Now, what does it indicate? If n is 3 means I have already done the arithmetic shift. Now I have to identify the values of Q1 and Q0. The value of Q1 and Q0 is 1, 1. So Q0 and Q1 is 1, 1. In that case, what is the action I should be doing? I should be directly doing the arithmetic shift, then minusing the content of the number. You know how many bits? N is equal to n minus 1 I have to do and check whether n is equal to 0 and repeat the process. Now it is 1, 1. Q1 and Q0 is 1, 1. Let me do the arithmetic right shift here. So arithmetic right shift I'm doing here. I'm retaining this 0 as is and shifting here 0, 0, 1, 1, 1, 0, 0, 1. So after doing the arithmetic shift, what should I do? I should do n minus 1. N is 2, 2 minus 1 is 1 for us. I'm sorry, n was 3 for us. So 3 minus 1 I did. So I got 2. This is the second cycle, right? So we got 2. Now what next I should do? Once it is done, I have to identify the values of Q1 and Q0. The values of Q1 is 0 and Q0 is 1. So 0, 1. So if it is 0, 1, what should I do? Go and check here in the flow chart. If it is 0, 1, I have to do addition, right? The content of the accumulator will be added to the multiplicand. Okay. Now let's do that process. So when I have to do a plus m, here m is a negative number for us. So a is, now what is the content of the accumulator now? Just check the content of the accumulator. Here now, after this process, it has become 0, 0, 0, 1. Correct? So put that value here, 0, 0, 1. M is minus m here. So when I'm doing a plus m, actually I'm doing a minus m. So what do I have to do is I have to take the two complements of m and add the content of the accumulator to the resulting m value. So 0, 1, 1, 1's complement of is 1, 0, 0, 0. Add 1 to it to get the 2's complement. The 2's complement value is 1, 0, 0, 1. Okay, so this value of m will be added to the content of the accumulator. What was the content of the accumulator? 0, 0, 0, 1. So the final value which I got is 1, 0, 1, 0. This is actually the content of the accumulator. Now go back to the table and put it here. 1, 0, 1, 0, 1, 1, 0, 0 will be like that only. We are going to take it from this value. This will be shifted here. Okay. Next, what is the Q naught value? It's 1. It will come as is here. So I have done A is equal to A plus M. Now, what is the next step? I have to do the arithmetic right shift. Correct. So go and do the arithmetic right shift here. So 1 will be here retained, then shift here 1, 0, 1. The 0 will come here 0, 1, 1, 0, 0. So this is arithmetic right shift. After doing arithmetic right shift, what I have to do? I have to minus the number of bits. Number of bits was 2. 2 minus 1 will be 1 here. So once I did arithmetic Right shift, I did n minus 1 and I have to check whether n is equal to 0. No, n is not equal to 0, n is equal to 1. Now, then in that case, what I'm supposed to do, I have to check what are the values of q1 and q0. q1 is 0, q0 is also 0. For 0, 0, what is the action I should be taking? See here in the flow chart. For 0, 0, the action I'll be taking is I'll be directly will be doing the arithmetic right shift, yeah, and then minus with n number of bits. N is equal to n minus 1 I have to do and check whether n is equal to 0. If it is 0, I'm going to end the process. Now I have to do the arithmetic shift. So let's do the arithmetic shift here. Right shift I'm doing. 1 is retained here. 1 will come here. 1 will come here and 0. This one will come here. 0, 1, 1, 0. So once I did arithmetic right shift, then I have to do what? N minus 1 I have to do. N was 1. 1 minus 1 is 0 here. So is n is equal to 0? Yes. So that is when I stop the process. Then whatever the content which is present in A and Q, accumulator and the multiplier will be the final result. So what is the final result? 1, 1, 1, 0, 1, 0, 1, 1. Now note that the first bit indicate the sign bit. So the first bit is what? 1, indicating the number is negative. In that case, what are we supposed to do? If the final value is negative, we have to take the 2's complement of that final value. Okay, so taking the 2's complement of this, what should I do? First convert into 1's complement, add 1 to it. Okay, the final value I'll be getting is 0, 0, 0, 1, 0, 1, 0, 1. So if I have to convert into decimal, the value will be, so all the bits 2 power 0, 1, 2, 3, 4, 5, 6, 7. Okay, so 2 power 4 plus 2 power 2 plus 2 power 0. 2 power 4 16 plus 4 plus 1 20 21. And remember the sign bit is 1. So put minus there and final result is 21. Okay. So this is how you do the multiplication of two signed numbers using Booth's algorithm. But if I'm doing unsigned numbers means we'll not have any negative numbers. In that case, the final value of AQ will be your result. You will not be doing this two's complement of the result in order to get the final value of your unsigned number multiplication. That is the only difference between signed multiplication and unsigned multiplication using Booth's algorithm. Thank you very much.